For those that are still working on the entry ticket, is there anyone, not entry ticket, but the do now? Is there anyone still working on the do now? No? Okay. Make sure you close down your computers because you don't need them right now. We're working on constant of proportionality. So today we're talking about constant of proportionality. And what that is dealing with proportional and non-proportional graphs. So we're going to start out going into proportional relationships first, and then we'll discuss more about what happens when they're not proportional. So one of the first things we're dealing with a proportional graph is to talk about the constant of proportionality. And think about what a constant is. It's just something that's always the same. It's the same way that you might have the same chore at home and that you do the same thing every day. Like my 8-year-old, his chore is to make sure that the couch is straightened up and do the shoes. He does this every day. And so because that's his constant, because that's his constant pattern, that will be his constant of proportionality. So we're going to talk about and look at what that looks like on graphs, on tables, and through an equation as well. So one of the first things we need to understand is when we're talking linear relationships, we're starting out with what the equation that everything is stemming from. So the equation everything is stemming from is y equals mx plus b. So y equals mx plus b. M is our slope. But one thing about the M, it has so many names. That's the one thing about math that makes me a little bit sad, is that they use so many names to really talk about one thing. So it means slope. It also means your constant rate of change. And sometimes it's not even a constant. It could be just a rate of change. So that's all the things that our M will be. And B is wherever it will touch. So it's the y-intercept. And so one thing you'll see is that whenever we're starting our notes, I'm always going to start us back here. And every time we're even working with numbers, we're going to always put it in an equation form so we can get used to seeing it that way. All right, so with constant of proportionality, all it's really saying is that if I have, like here, I have cups of mix and number of pancakes I can create. So one thing from here, what we can tell is that this will be our X factor because it's independent, and based on whatever cups we have is how many pancakes we can make. So that's our Y factor. When all I want to do is identify, are you constant or not constant, which means are you proportional or not proportional, I can always do Y over X for each one to see, do I get the same number? So 12 over 1, that simplifies to just 12. 24 over 2, that simplifies to 12. So if I notice that at least 2 spots I'm getting the same number, then that lets me know that this is a constant of proportionality. So here, your note portion. So a relationship is proportional when the ratio of y over x is constant, which means same ratio over and over. The value of the ratio of two proportional quantities. It is represented by the equation k equals y over x. K here is another way of just saying our M.
Good morning, Alpha Campus. Pardon this interruption. At this time, any student who is taking the credit by examination for English 1, please make your way to room 211 at this time. Please make your way to room 211. Thank you.
It doesn't apply to us. So Y represents dependent variables on tables and graphs, and X represents independent variables on tables and graphs. We use the equation Y equals KX to represent proportional relationships. So what does that really look like related to our original? That's just Y equals MX. Because what happens is if they are proportional, that means that my plus B is really just 0. Proportionality means that there is no, I'm not going to originally cross the y-axis.
I'm going to go through 0, 0, the origin. So this is what that really means in retrospect. So we're going to jump down and talk about it as on the table on what that looks like. So what we're doing is really just going y over x. So we'll say 6 over 1, 12 over 2, 18 over 3, 24 over 4. And what you will find is that they all will simplify to be the same thing, which is just 6. So if I notice that they're all constant like this, then what I want to do then, because I'm going to show us more than one way. So this is the first way. This way only works if they're constant. That's just the best way to put that. So that means my k here will be 6, and my equation will be y equals 6x. Now, for the second one, we're going to do it a little differently because this is going to be the standard way to do proportional or non-proportional. So remember, x and y are coordinates, right? So if I know these are coordinates, if I take any two coordinates, so if I take the first two, I want to know what my k is, or so what we will do is we will take the first two, so I will subtract, it'll be y1 minus y2 over x1 minus x2. So if I did y1 minus y2, or you want to make it, you can start from the bigger number enough. So if I said 15 minus 10 over 3 minus 2, I'll get 5. So if my k is 5, that means my equation then is y equals 5x. How do I know that? Because they are constant. There's no interaction with the 0, with the y-axis yet. And so you will see it when we move to graphs on what happens when it doesn't interact with that. To me, the easiest way when we're dealing with proportionality is to just go through and do y over x, y over x. And if you can get at least two of them with the same number, you know what your k is, and you'll easily be able to find your equation. So like if we did the same thing here, y over x, that's 4 over 8, 5 over 10, 6 over 12, and 7 over 14. So what is our constant of proportionality here? I didn't hear you. Did someone say something? I thought I heard a voice, but it was the faintest whisper. 1/2, thank you. So the constant of proportionality is 1/2. I love this problem because sometimes we get in the habit of thinking everything needs to start with the bigger number. That's not always the case. Y is always going to be the top number because it depends on x. So our constant of proportionality is 1/2. Our equation is y equals 1/2 x. So when we're looking verbally or in a word problem, it says the cost of 6 pounds of almonds is $23.28. What is the constant of proportionality that relates y, the cost of dollars, to x, the number of pounds? So they tell you what your y and x are. They told you that your y is the cost. So I know my cost has to be my top number, 23.28. And my x, number of pounds, is 6. And so when I divide those into each other, I'll end up getting that k will equal $3.88 per pound, because that's what that means. So if you notice that the constant of proportionality and rate of change is truly just a rate. It's like a unit rate. We're trying to just locate what is the original unit rate of a thing. So when we look at number 5, a car travels 220 miles in 4 hours. What is the constant of proportionality that relates y, total number of miles, so my y are my miles, and my x is the number of hours. So miles is 220 over 4. So what is my rate? Right. So my rate is 55. And I forgot to write this as an equation. Y equals 3.88x. And this one is y equals 55x. Constant of proportionality is probably one of the easiest concepts to learn in dealing with proportional graphs. It really is. But I still will have an entry ticket for you all in the morning just to make sure we do understand the basic concept of it. So when we turn the page, the X is always on the bottom because it's the independent. It's the same way. Think about how, like, if you have a younger sibling, they will never carry you. You will carry them. And so the dependent factor needs to be carried. So that's why Y is always on the top. And normally equations and things like that, word problems will always tell you what your X and Y are. You just need to know to put the Y up top. So here we're talking graphs. If you struggle with graphing, no worries. You'll get a lot of practice in this unit, as well as that if we need to do additional support on that, we can take time for that. So use the graph below to complete the table and answer the following questions. So first we need to write the coordinates. Can we go ahead and have someone tell us the coordinate points? Go ahead, Braylon. All right, so 0, 0, 110, 220, 330. And then you could say 440, but it's not necessary. So even just looking at it, you can kind of tell what is going to be the constant number that it's increasing. All right. So again, if we know we're doing y over x, we can't use 0, 0 because that's undefined. But we can do 10 over 1. So 10 over 1 because y over x. That's just 10. So you have to do this at least to 2 different ones. So if I even did 30 over 3, that's also 10. So I know my k here is 10. And so that means my equation is 10x. And it says, what does point 110 represent in the relationship? So what they're asking you for is, what does this graph really is saying? So what it's telling us is that at 1, that's the number of tickets. So we can say that one ticket cost $10. So what does 110 represent in the relationship? One ticket costs $10. Because that's how we'll interpret it. We have to use whatever the titles are on the graph. Go ahead and do number 7 for yourself, and then we'll have someone just show call. When you have it, just do a thumbs up. And when you have A and B. You got it, sir? Okay, we'll give a couple more people some time and then you'll just share out, okay? All right. All right, I see quite a few stop writing. Can you go ahead and share out for us? So y equals 3x. Awesome. So 3 is our k. And what did you write as your relationship? Okay. Awesome. Great job. So we kind of can see what the consensus is when we're dealing with constant of proportionality. So here's the last part, and then you guys are free to just do the next page, which is your homework page. While training at a marathon, Keith's watch reported the number of calories he burned and the number of miles, the mile marker. The data is shown. These are the miles and these are the calories. So our miles are our X and our calories are our Y, because your calories depend on how many miles you walk. All right, so we're going to just start at Nadia and just kind of go through the answers from there. So Nadia, is the number of calories proportional to the number of miles? Justify your thinking. So it's asking her, is it proportional? So we're learning about constant of proportionality. So we know we need to determine, or she needs to determine, what is are they showing that they're the constant or the same thing, at least in two areas, for it to be a constant of proportionality? And then Alara, you're going to be letter B, okay? Vanessa C, Riley D, and okay, well, still get to D, and Jordan E. Right. So is this proportional or not? Yes? Okay, can you tell us why you say it is proportional? Okay, so when she did y over x, she saw that 117 over 1 was 117, and what else? So there you go. That's all you will have to do to determine that that's a constant of proportionality, because two of them showed out to be the same thing. Thank you. B, what is the constant of proportionality that relates y, the number of calories burned, to x, the number of miles? Huh? You don't what? Okay, so what is the constant of proportionality, like what we've been finding, that relates y, the number of calories burned, to x, the number of miles? So remember, to find the constant of proportionality, we said we have to do y over x. So what will be y over x? What is our constant of proportionality here? Right, so it'll be 117 over 1. Well, I want you to understand, it's not just because you picked one of them. It'll be a constant of proportionality once you have done two of them, like you did in A, to say that the constant of proportionality is 117. So we know here that K is 117. Does that make sense? Because I don't want us to just, oh, it's only one. Because sometimes they'll trick you and give you one that's not a constant of proportionality. So we want to make sure we know that. All right, C, Vanessa. Write an equation to represent the relationship between the number of miles and the calories burned. What would the equation look like for this? Well, that's the constant of proportionality. Remember, we've been writing the equation every time that we do the problem. So what would the equation be for this problem? If we know what the constant is, which is 117, what would you write as your equation? Right, so y equals 117x. All right, D. The next day, Keith ran 7 miles. How many calories did he burn? So, Riley, how did you get 819?
So up there, it said number of miles and number of calories burned. So I looked at the 5 miles and the 2 miles and then just added the calories burned.
Okay, I love that he did something different. He saw 5 miles and 2 miles and added them together. That's one way to get 819. That's a great way to get 819. Another way is we can use the formula that we created, our equation. So we can say y equals 117. If that's x, and so if I plug this 7 miles in my x, so 117 times x, which is 7 miles, I still would get 819. So if I was to plug in for x, the 7 miles, that's how I can also get the same answer. But I love the way you thought about that. Very outside the box. That's what I love about math. There's more than one way to do it. All right, E for Jordan. If Keith's watch reported that he burned 1,170 calories, how many miles did he run that day? So if I know how many calories he burned, that means I know do I know X or Y? I know Y, so I can plug that also into my equation and solve for X. So what did you get? How would you solve for X, Jordan? Can someone tell him what would he do to get X by itself? Yes, ma'am. Divide by what? Divide by 117, because the goal is to get X alone. This is just a one-step equation. So Jordan, what are you left with? If you got it, you're free to move to the next page so that you can get it done before class is over. Jordan, let's look at it. 117 going into 117, how many times? 1. And then 117 going into 0, how many times? 0. So then how many miles did he run? 10 miles. All right, so please go ahead and move to this page. This page, if you notice, it follows the practice that we just did. You're doing the very same thing, including answering the questions down here. They relate to what we just saw as well, but they ask you to fill in the table. So remember, you have one set of numbers. Find that constant of proportionality, and you should be able to fill in all the other numbers. And it's due by tomorrow, the 28th. Of course.